airflow management best practices are as follows. Reduce the fan speeds for units with variable frequency drives, raise cooling unit temperature set points, manage the humidification requirements in the room, and turn off excess cooling units that do not have VFDs. And now we'll go through each of these in more detail. So when we look at fan speeds, it's possible to retrofit cooling units with VFDs or VSDs. They take various different names. The devices, the images on the right are devices that are used to do that. And adjusting fan speeds to meet the actual airflow demand of the IT equipment in the room is the easiest way to manage operating cost. It is the lowest hanging fruit. And whenever consultants come in to help try and save money on cooling, that's what they're looking for first. They're looking for the opportunity to reduce fan speeds because of the fan affinity laws. A 20% reduction in fan speed results in a 20% reduction in airflow, but almost a 50% reduction in the fan energy, the energy consumed by those fan motors. So you see here on this, these images of the fan affinity laws that airflow rate, the volumetric flow rate of conditioned air through a fan, is proportional to the fan speed. If there's a 10% reduction in the RPM, the fan speed, there's a 10% reduction in the flow rate of conditioned air. Pressure is proportional to the fan speed squared. So if there's a 10% reduction in fan speed, there's a 19% reduction in the static pressure. And power consumption, here's the real benefit here, power consumption is proportional to the fan speed cubed. So if you reduce the fan speed by 10%, there's a 27% reduction in energy consumption. Or as I just mentioned before, a 20% reduction in fan speed gets you nearly a 50% reduction in energy consumption. And you take that even further, a 50% reduction in fan speed gets you over an 80% reduction in fan energy. We're not talking single-digit improvement. This is 80% reduction in fan energy. So it's really important to look at bypass airflow and understand how much lower those fan speeds could be if the airflow management in the room is improved. Let's look at the next topic of improving efficiency, which is raising set points. By implementing these airflow management best practices at the raised floor, the rack, the row, and the row, IT intake temperatures become lower and they become more even. And that enables the adjustment of the supply temperature. And this is true of whether it's a return air temperature controlled system or a supply controlled system. Adjustments can be made to increase that supply temperature, and therefore the return air temperature increases as well. And the higher the return air temperature to a cooling unit, the more efficient it is and the higher the capacity that it has. Here's an example of a Liebert chilled water unit. And this is a cherry-picked example to just really point out the dramatic benefits that can be achieved by small changes. So you can see here that a return air temperature of 70 degrees Fahrenheit on that second row results in a 48% relative humidity. And at those conditions, this cooling unit has a total capacity of 64.5 kilowatts. It has 4.8 kilowatts of latent capacity at those conditions. What that means is that 4.8 kilowatts of that cooling unit's capacity are taken up by removing the heat given off by moisture condensing on the coils. Latent heat or latent cooling, as it's sometimes referred to. So we want to remove the latent cooling. We want to remove the condensation on the coils. And when we do that, by just raising the supply temperature, in this case 2 degrees, the relative humidity drops to 45%. The total capacity of the cooling unit goes up to 67%. And since there's no more condensation occurring on the coils, there's no cooling capacity consumed by that latent heat. And all of the capacity is sensible at 67 kilowatts. So that's an 11% increase in the sensible cooling capacity of that cooling unit with just a 2-degree change in return air temperature. Now, as I mentioned, this is a cherry-picked example. Obviously, if you go from 72 degrees Fahrenheit to 74 degrees Fahrenheit return air temperature, it won't be as dramatic because we've already gotten rid of the condensation on the coils. However, there are a lot of facilities that are operating with a small portion or a substantial portion of condensation occurring on their coils. And that's consuming a lot of energy and has the adverse effect of also removing the moisture, often requiring humidification to get that moisture back into the air. So let's talk about that a moment. Humidification control in the computer room is another very important aspect of saving money. Humidity control is most effective when it's applied as part of an overall strategy. It's most effective when humidification and dehumidification control, and that process is done from a centralized location. And all the humidification and dehumidification functionality in the individual cooling units is turned off. Either that way or with cooling units that are talking to each other and they know what each other are doing. Because as many of you have probably heard, cooling units can fight each other. One cooling unit can be trying to provide humidification, and right next to it is a cooling unit that is attempting to dehumidify the air. And this consumes a great deal of energy. So let's look at when you do not have the ability to reduce fan speeds, just turning off a cooling unit. How much energy is there consumed by these fan motors? So a typical large cooling unit that might have 2 10 horsepower or 7.5 kilowatt fan motors consumes 15 kilowatts of electricity 24 hours a day, 365 days a year, of course. And at an average cost of 10 cents a kilowatt hour, that results in over $13,000 of electric bill for that one cooling unit. So if you can turn off a cooling unit, you can save $13,000 a year. That adds up a lot, and that number is even greater if there are variable speed drives on the variable frequency drives on the cooling units. You have greater energy savings if you reduce the fan speeds of all the cooling units in the room compared to turning off several of the cooling units in the room. It's necessary to implement airflow management best practices to the full extent possible to maximize the number of cooling units that can be turned off or to maximize the fan speed reductions that are possible.